Good morning, everyone. I'm Uma Maheshwari, AP AAA Department, RMD Engineering College. This class, I'm going to take the video of the session. The topic for today's session is Lvdt, Linear Variable Differential Transformer, or Linear Variable Differential Transducer. So here the transducer which converts one form of signal into another form. Here the conversion happening here in linear variable differential transducer is the linear displacement is converted into the electrical signal. So the linear variable differential transformer, it is a passive inductive transducer and it is used in many applications. The widely used inductive transducer is to convert the motion into electrical signals. The linear displacement is converted into electrical signal. Now moving to the construction of the linear variable differential transducer, it consists of a single primary winding. This is the primary winding and two secondary windings, S1 and S2. It is wound on a cylindrical former. Now, when a sinusoidal voltage is applied in the primary winding, we are exciting the primary winding. The two secondary have equal number of turns. The number of turns in the secondary is equal and they are identical and they are placed on either side of the primary winding. Now, the primary winding, it is connected to an alternating voltage source. And you can see a movable iron core, soft iron core is placed inside the former. Now, the displacement which is applied to this soft iron core is measured here. Now, this core is made up of high permeability nickel ion. And this assembly is placed in a stainless steel housing and in order to provide from electrostatic and electromagnetic shielding effects. And the frequency of the applied primary winding supply is from 50 Hertz to 20 kilohertz. Now, the primary winding, once it is given excited, it produces an alternating magnetic field. So this alternating magnetic field in turn induces the alternating voltages in the two secondary winding. Then the output voltage of secondary winding S1 is represented as V01. And the output voltage of the secondary winding S2 is represented as V02. Now this windings, it is connected together in such a manner that they are in series opposition. S1 and S2 are series opposition. So the differential voltage is applied here. So the differential voltage is represented as V0, which is equal to V01 minus V02. Now about the working operation of the Lvdt. Now there are three different cases in order to explain the working operation of Lvdt. The first case is the null position. That is when the core is in the null position. The flux linking with both the secondary winding is equal. In this case, the primary winding flux linking with both the secondary windings are equal. And EMF induced in the secondary windings are equal. So at null position, the voltage generated here in the secondary winding is, let me represent here as ES1, and the voltage generated in the secondary winding is represented as ES2. So when both the voltage ES1 and ES2 are same, the differential voltage E0 is equal to 0. This is at null position. Now the second case, if the core is moved towards the right, when the core is moved towards the right of the null position, that is ES2 will be, the magnetic flux linkage with the ES2 will be more than that of the ES1. So the output voltage E0 is given by the differential voltage, that is ES1 minus ES2. And it is out of phase with the primary winding. The amount of voltage in either the secondary winding is proportional to the amount of movement of the core. Okay, how much ever the voltage differential is there, that is equal to the displacement of the core. So here you can see that with respect to the linear motion, it is we are able to obtain the voltage magnitude. So here E0 is equal to ES1 minus ES2. Since ES2 is greater, we are obtaining a negative voltage value. And with respect to the movement of the core, there is a change in the magnetic field and there is a change in the electric voltage. So the displacement of the core is converted into an electrical signal. And the third case, the core is moved towards the left of the null position. So here when the core is in the left of the null position, more amount of flux linked with respect to the S1 compared to that of the S2. So ES1 is greater compared to that of the ES2. So the voltage generated is E0 is equal to ES1 minus ES2. Since ES1 is greater, we are obtaining a positive voltage. So it is in phase with the primary voltage. Okay, the magnitude E0 is positive. So you can observe here, with the displacement of the core, we are able to determine the voltage magnitude, and thus we are able to determine the direction of motion. And this is the curve for your output characteristics of an Lvdt. So this is the null position, and if the core is displaced towards the left and displaced towards the right, what is the output voltage obtained? So here we are able to observe that there is a linear variation for the core displacement to the left of the null position and to the right of the null position. At null position, the output voltage is 0. Advantages of the Lvdt. Here, in case of Lvdt, it is used for different applications. And here in this Lvdt, there is a linear relationship. It has high sensitivity and it has high resolution, and the readings have a good repeatability. The Lvdt consumes lesser power and they produce low hysteresis, and the frictional losses are very less in case of Lvdt. Whereas it has some disadvantages. The disadvantages are it requires large displacement to get a considerable differential output, and it is sensitive to stray magnetic field and requires shielding effect. The temperature and vibration affects the output of the transducer, and the dynamic response is being controlled mechanically. These are the disadvantages of Lvdt. And now with respect to the applications of Lvdt. So to measure the displacement with ranging from few millimeter to centimeter, the Lvdt is used. It can be used in both primary and secondary transducer. It is used with the board-on tube in order to measure the pressure. It is also used in servo mechanism and other industrial applications. Thank you, students. Thank you all.